Hello guys again. All right. Today I will talk about the image and the image pre-processing. So I will talk about how to open the image, how to scale the image, and how to use multiple images one time, how to find the mean and standard deviation for the image, normalize the image, the augmentation of the image, and saving the image. Okay. So let's say look at this example, guys. This example is called puppy or muffin. This is very famous example, and even the humans sometimes we cannot determine in the first impression if this let's say this muffin, but maybe somebody we think it is puppy, and this the other size. Okay, so if we try to feed the neural network this data set, the neural network will not understand what is the difference between the puppy and the muffin unless we apply data pre-processing. So the data pre-processing make it easy for the neural network to classify the image. That's the first thing. Second thing, guys, the data set, the image is supposed to be with the same size because the input data for the neural network is supposed to be just one size. If I say this neural network is 3, 4, 5, 5, that means we need to, every time we have an input data 3. So if we have different size for the image, it will be different. We need different neural network. For this reason, we apply data pre-processing, and in this data pre-processing, we will resize the whole images on specific size, in one size. So we can apply neural network. So here, I will show you this in the code. Okay, but what this means, guys? That means here you are familiar with the NumPy, you are familiar with the matplotlib, but here the new thing here, the BIL, which is a public imaging library, and from the BIL we will have a class called the image, and here also something is called the glob. What's a glob? Glob, it is a function or a set of function enable us to get inside the folder and try and find what is the same files with the same pattern. Let's say with the same pattern, I mean maybe we need the files that we had has extension GPG. So glob can find these files for us and return it to us. Okay, what about these rows, columns parameters? 5, 5. That means each image you will see in this code, it will be 5 inches times 5 inches. All right. Okay. Also, the images come with many warnings, so we need to ignore these warnings. All right. Okay. This I will code back to the code now, and I will show you these parts. All right, because it will be easier to find it with the code. Collab. Let's start with the open notebook data. Image pre-processing. This is the same code we just saw it now. All right. This the matplot.library. All right, and this NumPy and this image from public imaging library. All right, and this globe. Okay, and this 5 times 5. That means all the images in this page it will be 5 inches times 5 inches. All right, and this how to stop the warnings. All right. Here, guys, I have an image. It's called the TUD GPG. I think I don't have it now. Let's download any image from here. Okay. All right. TU Dublin. Right, let's say this TU Dublin. TU Dublin. Logo. Okay. Anyone you like it? You like this? Okay. Let me download this. All right. So save image as PNG. Okay. I will put it in the download. Save. All right. Okay, so here this the one I was using here was GPG, but I will upload the new one. I just downloaded now. It's TUD PNG with a capital letter. So okay, it gave me a warning. This warning said once you close this session, I will delete this one. Okay, you need to keep this image in your computer. All right, so here I copy the path and I will come here. Here, guys, for now, if I say, oh, I did run this code, so I will run this code first. All right, now, then I will run this code. Now I read this data, I image this, I open this image. Okay, let me show you how to show this image, this code right here. So the BLT image show my image because I name it my image, and this BLT.show. If I see this, so you will see, you find the image here. Okay, of course, guys, if you change this for 3 times 3, is in this page will be 3 inches times 3 inches. Okay, guys. All right. So this about how to represent, how to show the images in this page. All right. Okay. Here, guys, how to convert the image to grayscale. What is the L? L means one layer, one session, so one layer means we have one channel. That means if we have the data RGB, so we have 3 channels. Each pixel in this image, if it is RGB, it contains 3 different numbers. One for R, one for red, one for G, for green, and one for blue. But if I would like, so each image, it will be 3 matrix. Look here, guys, you imagine this image as a matrix. So rows and columns. Each pixel is a cell, and each pixel represents a different number from 0 to 255. But if it is RGB, so each pixel here is 3 numbers, not just one. One for R, one for G, one for blue, RGB. Okay, but here I'm trying to convert it to one layer. So I will combine this to one layer. So this will be grayscale. So my image, this image, I convert it to one layer. I will show it, how to show it. It's right here, show it in grayscale. All right, and I give you CMap, color map, gray. All right, if I run this code now, this will be grayscale right here. Okay. Of course, guys, if I didn't mention what is a CMap, it gives me something it's called is like you choose the different map, and it's not what the channel you want. We want the channel grayscale. So the grayscale, it will be easier. Why? Because each pixel will have one number, just one number from 0 to 155. But in the original image, this one, each pixel here, because this RGB form and this grayscale form, all right, state. So this form, guys, give me for each pixel 3 different numbers. Okay, one for R, one for G, one for B. Okay, so this is the first thing. Guys, here also I want to show you another thing. Can we access a folder full of images? Okay, and this folder that's full of images, we can navigate inside this folder and show the folder and convert it to the grayscale. Yes. So how to do this? Okay. Actually, I'm not sure if I have this folder again. Let's check. I don't think I have it in this computer. So I will download different images now and we make folder together, and then we can show the images here. Let me see here. Okay, faces. Okay, in images. All right. So what is no, this small image? Okay. So let me click here. Okay. Save as. Okay, let me name this one. Like this from type GPG. It's okay. Enter. Okay, I downloaded. Okay, let me do something with the colors. Yeah, you know these people. Okay, save as. Using these two. And okay, in the 3, save as. 3. Okay, and I will come here, guys, right? And I will create a folder here, new folder. Let's name it images. All right, and uh, I will upload the folders, the here, and let me hide it here inside these images. So if I open this, it will be 1, 2, 3 here. Can you access these images and show me all the images that's into GPG? Yes. How can we do this? With glob. So glob is abbreviation for global. All right. So what the glob can do, can access this folder and show me all the images with this form, this template, with this any name, any names, but .gpg. Okay, perfect. And then I will, after I access this, I will open it. The same thing here. Look here, guys. Look here, guys. Image.open, and they give you the link. So here, for any file name inside this folder, image.open file name, and I name it IM. And then I have an empty list here called the image list, and I will append this image. So when this loop finished, I will find image list with the three images. Correct? Can you show me this? Yes. For each item in image list, print the item, and then show it to me. Show it to me as an image. Okay? Can we do this now? Yeah. Let's run the code now. So you will not find these images. You will find this the images we just use it now. Yeah, there's the first image, second image, and third image. What is the second image? So we have two images. What that means? Let me see what that means. Okay, guys, this image not with the template GPG. Got this? What about if I try to name it? GPG. Okay. Let me run this code again. Yes, we done it this time. Correct, guys? Why GPG? Because that's what we mentioned here for globe. We told globe any image with this extension, show it to me here. Okay, so this is the image, guys. This is the image. This is the name of the image, and this is the mode of the image. The mode of RGB. RGB. Extension. Sorry. 1 second. That extension. Okay. All right. Now the mode here is RGB. RGB, that means each pixel here, each pixel. Look here, guys, each pixel. It will be 3 values. Each value of them between 0 and 255. Okay, value for red and value for green and value for blue. So these are basic colors. Okay, what is the size of this image? This is the size of this image 1,689. This size, this is a width here. Okay, and what is the height? The height 1,303 is the height of pixels. Okay, what this number? This where this image started at your RAM, at your memory, the memory address. Okay, the other image, of course, also RGB, and this is the size 1,000 times 800. This 1,000 times 800, and this is starting. This image is smaller. This RGB as well. Okay, this 1,000. This the width here 615 times this length. All right. So how can we do this with the same function? This function. But before we do this, we go inside the folder to find any name and add it to this list, any GPG, and to add it to this list, append it to this list, and that's our job. This we done now. Why you show me this? Just I show you if you want to represent, if you want to see the images, that's how to see the images. Right? Can you resize these images? Why we need to resize it, guys? Because they are different size. They are different size. And if we would need to use them in neural network, we cannot do this. So we need to resize it. It's better to resize it smaller, like what? Like 28 times 28, like 56 times 56, like 128 times 128, and no more than that. All right. So I will resize it now to 28 times 28. Okay. So I will create a new list. Okay. And I say image in image list. Where is the image list, guys? This image list here. So I fill the image list with the three colors, with the three images here. But here I say for each item, this item resize it with this width and this height. Okay. And then append it to the new list. I name it here new image. All right. Then we done here. We resize it already. Can you show it to me? Yes. For each item in this list, which be okay, print the item and print and they show me the image and BLT.show. Okay, let me stop this. You guys, how all the images, it was 5 inches on 5 inches, and it was RGB 28 times 28. Let me run my code now. Figure, guys. Yes, it's 28 times 28. All right. RGB, and each one of them the size 28 times 28. So this is the first step. We need to understand how to resize your image. Okay, how to resize your image. Right. Of course, guys, if we come here and we change this the rows and column parameter to 4 times 4, so every image here in this page, it will be 4 inches times 4 inches. Okay, this is different than the number of pixels. Okay, so I will run time again. I will run all again. Is 4 times 4, and yeah, maybe we need to do. Okay, here, guys, look here. Is another way to resize the images. Okay, so what is another way? Nothing different, but this. Look, guys, I just add this. Look, guys, this is the same code. The new list here, and each item in the image list, okay, item resize, and they give him the width and height, but I add this parameter. This parameter is called the image anti-lies. That means the image will not so pixelized like this. You know, the pixelized, each pixel by itself, it will be more smooth. So if I run now, it will be the same thing but more smooth. And I append it here and here. So this my job. Now to resize it and put it in some list. But here I'm trying to access this list again and print the item and show it to you. Okay, so I don't need this now. This, and I will run the code according to this. So yeah, give me the same image, maybe more smoother than before, but still 28 times 28, and the mode is RGB. Okay, now let me show you how to convert the mode to the L. All right, with the L, just one layer or one channel, which will be grayscale. Okay, let me show you how to access a whole folder and do the same job in this. Okay, so here, okay, this grayscale, I name this list is grayscale, and each item in this list, okay, converted to grayscale. So each item here, this item convert to the L mode, okay, to L mode, and I name it grayscale M, like grayscale images. Then I embed it here. So if now after I run this code, this empty list will have 3 images. These 3 images, but in grayscale mode. Okay, let me show you this. Inside this grayscale, this one, I print the image and I will show it to you. So now the mode is L, one layer, and the size is 28 times 28, and this is where the RAM memory started. Okay. Okay. Another thing, guys, in data pre-processing, to find the average of the images. Why we need to find the average of the images? Let me show you that first. What is the average of the images, and then how to how what is the benefit come from this. Okay, so I will I will convert each image of this 1, 2, 3 to numpy array. Why? Because it is image now. I need to be a matrix so I can make some calculation on these images. So I convert to numpy array for the first image. Why this first image? Because guys, if you look here, you come here, guys. We'll add one more code here, right? And they will ask you what exactly inside this grayscale copy. I cannot access grayscale like this. I need to access grayscale through a loop like this. But I can access one item by one item like this. What is the 0 here? Okay. So if I say 0, it gives me this image. What this image, guys? This 28 times 28. What about 1? Okay. The second image. What the third one? Oh, there is no third one. Why? Because I have 3 images. Number 0, number 1, number 2. Okay, we don't have third one. But if you want to see this in PLT, okay, so you need to say plt.mshow, and this one will be use the same parameter you applied here in PLT, which is 4 times 4. Okay. I hope you get this clear, guys. All right. So here I put the only first image here. I converted to numpy array. Why? Because I will loop the third and the list of images, and I will add it to this array. Okay. So this now is array contains only the first image in float mode, float like decimal numbers. Okay. And then I will ask him for any image inside grayscale starting from 1. Why? Because the first image number 0 already inside these. So from this, add for this variable, add numpy array for each image. So here I'm trying to say if I have 10 images, put the first image here, and from 1 to 10 or from 1 to 9, okay, add this to the same one. So what this has now, this numpy array for the submission of all images. Now I will divide it on the length of the array. So the length, that's number of images. Now I get the average. So here I get the average, right? Can I change the parameter? I change the parameter to 10 times 10, and I will show it to you in the grayscale. So if I run now, these images. Well, these guys, the 10 times 10. Okay, if you don't like it, let's make it 7 or 5 times 5, whatever you want. All right, so better to be square. Okay, with this one. What this means? That means that the all images together. What this could represent? That can represent highlight the specific feature and reduce the noisy. Like what? Like if we look for these images, guys, maybe one of them has a glass or wearing a cap or wearing anything in her head. So it will, from the average, will not appear here. Okay, will not appear here. Well, guys, well, will not appear. But the thing would appear here. The thing will represent specific feature like nose. But if we have the same image in all images in the same position, so they will know the nose come over the nose, come over the nose. So we'll see that in the average here. But what did they think? This be used, guys, for medical images, because medical images, guys, take the same position. So if I get the average, I will know if any what is the piece, what the features here, and what is the noise here. Maybe the medical images to the heart, to the bones, to the stuff. So if I take many images and I get the average of them with the same position, I will know what exactly what the high feature, what is the feature, and what is the noise here. Okay. By the way, here, guys, I hear what this for this because I ask you here. After you convert it to this, I print it. So look, this will be the image, guys. Look at the image, guys. What this is the image, right? It's in NumPy array. What this image, it will be 28 times 28. Okay. All right. Now let me show you how to save the image. So to save the image, guys, it's easy. It's easy task. Just come here, right, or in the same folder that your Jupyter notebook work, right, and just make a new folder, and this folder give it any name. In my case, I name this folder. Okay, so this is the name of folder. What this is the name of the image. I name the image and dash, and then I give him the index. The index means 0, 1, 2, 3. Okay, and then .jpg. Okay, guys. So I name it image, and this is okay. So for each index and image in the grayscale, it's a grayscale, the last one we have. Let me see the grayscale. Yeah, this grayscale. So I'm trying to save this grayscale. These grayscale images, right? Because we don't have image here, just the average here. Okay. So if you look here for the process, the image, it's empty. I just create it now. But once I say, oh, for all images in the grayscale, put it, save it. So run it now. Okay. Let's see what happened here. Yeah, look at guys. We have 3 images. Image, this image, that's the name I give it to image, and the dash, and the index in string. So 0, 1, 2, and .jpg. Okay. What this image? This image is really lovely. For the second image, for the third image. Okay, so this is about how to save the image. Now, how to normalize the image. What the normalization means? Normalization means instead of the number between 0 and 255, let's make it between 0 and 1. What the purpose of this? The purpose to make the calculation more easier, right? So how to do this? Just divide the data, the image, on 255. But what is if the maximum not 255? Okay, if the maximum not 125, so I would divide the image on the image dot max over 255. Okay, so that's this how to normalize the image. How to normalize the image means to put the whole image between 0 and 1 instead between 0 and 255. Okay, so how did you do this? I set the parameter again here. I don't need to do this. Okay, you can change it to 3, 4, 5, whatever, but please keep it square. All right. All right. And here for any index and image for the grayscale, all right, I convert it to NumPy array. Why? Because how could you divide it on the number before you convert it to NumPy array? Oh, that I understand now. So you ask me to convert it to NumPy array and then apply this normalization and then convert it back to image. Okay, but this division cannot be applied to image. We need to apply to array, to numbers. So here, guys, look here. This is the image. I convert it to NumPy array, and then I will take this image, which is NumPy array now, and I divide by 255. I can see just 255. It's okay. All right, this is okay. But if you expect the highest level, highest number, not 255, by the way, 255 in grayscale, it will be wide, right? Right. So also, if we have RGB, so 255, 255, 255, 255 red, 255 blue, 255 green, it give you a white color again. Okay, so after this scaling, I print this. I will print the normal, the image again. All right, and then what I'm trying to do here to convert it back to image. So the image from array, I will take this the small images and I put it back in the form of image. And I convert it to RGB. Look. Why? Because this mode, it will not be RGB. With this mode, it will be something called GBR, right? talk about this later, right? I convert it to RGB, and I will save it here, right? So, and then I will show you each image for each one, right? Let me run this code and see what happened. Sure, will give me an error because I don't have in this directory the folder with this name. Let me first create a folder. Okay. So this normalize this empty right here. Let me run the code. So guys, I printed the norm. This is the norm. Look at the numbers here. Sorry. Let me something. Second here. Yeah, here. I don't need this. Close this. This is the norm image. Okay. And then I convert it to image, and I save it in this, and I show you each normalize each image, and it's okay. If you come here in the norm image, you will find the 3 images I just created. All right, guys, do you have any question here? I will stop here for 5 minutes to ask you if you have any question. Hello? Still there? Adam, how are you? Raymond, Adam.
Good. Just like the purpose of this, I'm just unsure what the purpose is. Are we? Is it? It's just a preparation, bringing images in and preparing them, and for classification, or
yes,
what's the real world application, I guess?
Yes, it is classification and all this preparation to make it easier for neural network to classify the image. Okay, I will show you a real example now in neural network. What that means, I give you like two breeds of dogs and how to classify them. Both of them dogs, but how to classify them. Okay, so we will do this now. But this only this data pre-processing to make it easy for the neural. If we come back here, guys, to these slides, you will find the same thing here. How to open multiple images. We already done this. How to create a folder the type RGB. So, and here, these are some images and the same code, all right? And give different images than what we have, all right? And here I'm talking about the neural network, and we cannot put different size, so we need to put this in 228 times 28 or 56 times 56 or 128 times 128. Okay, and what the code looks like, the same thing. And this so guys, every slides here we already done these slides. Okay, the code. Okay, and this average, guys. This is average. Right? Look, it's guys. Something it is, doesn't have meaning, but it is very useful for a specific reason, like the medical thing. Look here, guys. These 3 dogs, we got the average. So this dog was wearing something here. It does not exist here in the average. Why? Because it is noisy. But maybe you can find the nose or eyes or what's called the ears or something. Anyway, this average doesn't apply for the regular images. We apply for specific images like this. How to save. So I will, from here, I will talk about another thing then. But I will skip this part also. I will come back to this, but I will show you this part in code, and then I will come back to this. Okay. Velina, do you have any question? Kian, do you have any question?
No, I'm okay.
No, all good.
Okay. So where you find this code, guys? You will find this code here. Show it to you. I can upload my code for you as well. This code we done there now, I will upload it for you, but also you will find it somewhere here. Yeah, so it's this one. Okay, so this is the code, right? The same code here for the images, not our images we use it now, the images I used it back then. Okay, so there's a code, same code we just generated now, right? All right, let me open a new folder and I will tell you now. What about if I have some for this? I name it here. Dogs example. Okay, let me show you this example in particular for dogs. Right. Look here, guys. If you come here, you will find uh, the something about dogs here. 1 second. Data set, a big data set for dogs is made by big university, Stanford University. This data set. Look here, guys. If you click here, you will find images and you will find this many breeds. Did I pronounce it correctly? Breeds, right? Breeds of dog, right? I hope I pronounced it correctly, guys. So each one full of images. Yep. So look, open any image for this. So different dog. So you find it in your model page. Many images here. You don't need to download anything from online or something. Okay. So actually, guys, I download one of these. I come here and I will tell you which one already I downloaded. It's called the toy something. Yeah, told it to rear or something. All right, so I come here and download it. Finds many images, and the images is high resolution. So we need to scale it to make it smaller for our neural network. Right here. Okay, let's show it to you here. All right, I will name these dogs. All right, let me first to unzip it, extract it, extract the file, extract here. Okay, this one, extract here. Okay, so look here, guys. This is a full of images. Right. And I will try here to apply data pre-processing on these images. Okay. For my case, guys, I upload this to my drive, so it's easy for me to find it here. You need to upload it on the same drive, same directory, the Jupyter notebook you are in. This is in my drive now. Okay, so I'll come here. Okay, guys, I will do the same again, the same thing again and again. All right, I will come here, run the code, this code to read the image. All right, from matplot, PLT, and the numpy, and this is the important part. BIL, which is public imaging library. Okay, and this group, what the group can do, group can navigate inside the folder and show me all the files with the same extension. All right, and this row and columns parameter, so each image here it will be 5 times 5. Okay, and this to stop warning, and is the same thing, guys. What I'm gonna do to open the file, this image list empty, I will use globe to navigate inside this folder and show me all images with the extension GPG. Okay, and open each file image and put it in IM and append it to this list. So I've done now. This is my job. My job is done. But just to show you what exactly I've done, okay, for each item in the image list from 0 to 10, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 images from 0 to 10. 9, we'll stop at 9. Okay, print the item and show. All right, so run this code. Will access my drive first, and then he give me the number 0 and number 1 and number 2 and number 3 and number 4 and number 5, number 6 and number 7 and number 8 and number 9. Okay, look here, guys. Each one with different size, RGB, and this size, RGB, and different size. Each one with different size. And this data set, you cannot use neural network or even statistical method, all right, to classify or to access this data. So we need how to scale this data again, right? W and the width and height. Okay, I name this new image scale, the new list, and for anything in image list, this image list I just created before. Okay, resize it and image anti alias and append it to this scaled image. So my job is done now. But here to show you what's inside this image scale, I show you number 0 and 1. Number 0 and 1. So I just use the first two. Okay. So if I run this code, it's the first image. It was like this before. This one, but it's high resolution. This one, 500 times 375. But actually, the one I use with low resolution, 28 times 28. So this is the size I need for my neural network, right? And this is the second one. It even was they were different sizes. Now it is same size. Okay, but unfortunately they are RGB, so I need to convert them to grayscale. So I create grayscale test here, and in each image, just I convert it in scale to way to image scale. Okay, convert it to L mode. L mode means one layer, one channel, right? And append it, I name it grayscale image and append it to the grayscale, right? So I done now, right? What you find here, correct here, show me the grayscale, the first 10 items. So if I run this code, is the first. Look, each one of them in the mode is L and the size 28 times 28, each one. Okay, and here you understand what I'm going to do to find the average. So I put the first one in this variable, and from 1 and on until maybe we'll have 100 image or something, all the images. How many images we have? I don't know. See, where guys here. Okay, close. It is in download, so correct? Download. I name it something. Is the file correct? I think I unzip it already, right? Where I unzip it? Yeah, this one. Yes, yeah, this one. How many images there are? We have 172 images. Okay, is the image. All right. So I will get the average of all these images. All right. So after this, I take this variable. This variable now has just the first image as NumPy array. So I will convert each image after that as a NumPy array and add it to this variable. And then I will divide it by the length of the list to get the average. This is the summation. This is the average now. And I print this average. And then I will show you to here. Let me run it. This average. I know it doesn't make sense for some of us because this is not what we do in regular images. We do this in the medical images, all right? So here I make it 10 by 10. I can make it 3 by 3, 4 by 4. Okay, I mean this presentation. Now I need to save these images. So if I need to save it, exactly like we done before. I need to have a folder with the same name here. Sorry. Okay. So this empty folder, if I run this code, it save all the images in grayscale, and you will give this a name. Give the image underscore and the index. You can change whatever you want here, guys, but this is the way you like it. Okay, it's not 99, it's more than that, 170 something. Yeah, 100 something here. Okay, okay. So that's how to save the images. Okay, how to normalize it. Normalize it, I will divide it by this number. Okay, but first I need to convert it from image to NumPy array, and then I normalize it. And if you want, I will convert that to image just to show it to you, and then I will save it in the new folder. Let's look. Folder. Okay, this normalize is empty, but once I run this code, it will show me not that much. It's still working. And here, oh, how many images I'm trying to show you here? Oops, I will try to show you all images, so that's not wise because this code will be run for a long time. He will try to show me the NumPy array, and at the same time he will show me the image grayscale plus resizing. All right. So this is what happened here. Okay. Do you have any question, guys, about this? Hello. Not yet. Raymond, Evelina, and Kane. Yeah. Do you have any question? Everything okay?
Yeah.
So
A lot of it.
yeah, we need to do this yourself, I'm sure. Okay, right. Just I want to show you one more code here. Okay, so this was image processing, this video flow, and this. Okay, you don't need any of these. Right, and here this processing. We don't is the same code here, but maybe he with this code for another breed, another folder. So this is a code. I can share the code at the admin. So here, this was the code. Now I will move to how to apply the neural network for the. Are you ready? Ready, guys? All right, I think you are ready. All right. So first, guys, I would like to show you how to do this in classification. See the screen now. Huh? Let's say we have two breeds, guys. Two breeds. Let's name the first breed dogs one. And second breed 2. This is a folder, guys, full of images. And this is a folder full of images. Got my point, guys? So if you go to the standard, the Stanford data set, and download 2 of these breeds, right? 2 different images, right? So I will do this now with you. And this is I will rename the first one. I rename it Dogs1, and I rename the second one Dogs. All right. So how many steps we need to apply this to neural network? Let me do this. First step, guys, is step 1. Step 1, guys, we need to resize. Sorry for this. Oh, why did we insert? You remember how to add text? To add text, I forgot how to add text here. Okay, insert, I think insert. Okay, I will. Okay, here the step one, guys. What I need from step one, guys, I need to resize. Guys, I give my types resize and plus grayscale. Okay, for both of them. So the step one here, step one, resize and plus grayscale. You got this, guys? So what exactly I download? I have two things I need to classify them: apple and orange, bicycles and cars. The first breed of the dogs 1 and dogs 2. So I will put this in folder, the all images for dogs 1 in folder, and the all images of dogs 2 in other folder. I have two folders. So I will come to the first folder and I will resize and apply grayscale, resize and grayscale. Okay, now I need to convert this to X and Y. So I will have a list called X. Therefore, I'm trying to make X and Y. How to make X and Y, guys? To make X and Y, the step 2, to make X and Y, you need to convert each image to NumPy array. Okay, and then append it to X. What is the X? X is the empty list. What is the Y? Y is the empty list. Okay, Y is the empty list. All right, so I will put this here in. Okay, so what do you expect, guys? You expect this, right? So the X, it was empty list, and you put the first image. So the first image will come here, 28 times 28, 28 times 28. All this array first image. Then I will add the second image, 28 times 28. Then I will add the third image, 28 times 28. You got the point? In the same time, guys, for Y, I will put for the first image 0, second image 0, the third image 0. I will keep doing this until I finish the first folder. Then I will go to the second folder. I keep convert it to NumPy array and append it to X. 28 times 28, 28 times 28. But in this time, in this folder, I will name it 1, 1, 1, 1. So this will be the input, and this will be the output. You got the point here, guys? You can understand why I'm trying to classify between the two breeds. So this input, it will be the image itself. The output, it will be this label, 0 or 1. 0 from the type 1 or 1 from the type 2. You got it? Yeah. Not so much. Right? Here, again, what I'm trying to do here, after resizing and grayscale, I convert each image to NumPy array. All right? And after I convert it to each image to NumPy array, I form X and Y. How to form X and Y? This image NumPy array, append it to X. Put it in X, add it to X. And at the same time, if you are here, okay, put in the Y0. Second image, convert to NumPy array and put for the Y0. The third image, convert to NumPy array and put it in X and put in the Y 0. If you finish with this, go to the other folder. The first image, convert it to NumPy array and add it to X and put Y equal 1. The Y equal 0, the Y equal 1. So instead of I have two folders now I just have X and Y. What is the X? X is the images itself, 28 times 28. What is the Y? The Y is 0 or 1. 0 if it belongs to the first breed, and 1 if it's belongs to the second breed. Clear, guys? Not so much? Okay.
That makes sense.
Makes sense. Thank you.
Yeah.
That's really.
Yeah.
Now, guys, don't forget that the X and Y not NumPy array. They are lists. So we need to convert the X and Y to NumPy array. All right? X and Y, I convert it to NumPy array. Okay? And now, after this, I will reshape it. Shape. What does the reshape means? If you look for these X and Y, look, guys, let me do this. This 28 times 28 represent the first image. 28 times 28 represent the second image. 28 times 28 represent the third image, and so on. This not happen. This doesn't supposed to happen. Supposed to have for all image one line for the first image, and one line for the second image, one line for the third image. So how can we do this? I will reshape this instead of 28 times 28. Actually, this 3D array. Why a 3D array? The number of images. Let's say we have 100 images. Okay, times 28 times 28. To convert it to this thing, right? I should supposed to say 100 times. Oh, so how can I make this 28 lines here to be one line here? This reshape. So I will come here, the first line, and then I put it beside the second line, and next to the third line, and third line, until I finish the image. So this 2D array will be 1D array. Okay, so 28 times 28 is equal 700. 700 what? I forgot. Okay, 28 to 28 times 28 give me 784. So it will be 784. So I convert this from 100, which 100 is image, maybe 125, I don't know. But in image, it was 28 times 28. It becomes just now, the image is 784. Just why do you need this? Because you need to feed your neural network with this as an input. So the neural network, remember what the neural network looks like? There's the input layer, and this hidden layer, and this output layer. So this input layer, guys, is supposed to be 784. So each pixel, it will be input here. That's why I make the image so small. Because look, guys, even it's very small, 28 times 28, but the input layer for the neural network give me 784. Okay, all right, guys. And then if you remember, we do this. And finally, we have this. You remember this neural network? I hope so. This is the input layer, this is the hidden layer, and this is the output layer. What the output layer say? The output layer say either 0 or 1. 0 if it is first breed, this one is the second breed. Okay, so here I'm coming back here to show you. So I make the reshape plus maybe I need normalization. Normalize. Okay. Also, guys, I need to shuffle it to mix it together. So I I don't need to have the first 100. It will be from dogs 1 and second from 100 from dogs 2. I shuffle it together. So this is the third step. Third step, step 3. I will come back to this when I do the code, right? Let me just here, the first thing, I will put each one in different folder, and I will apply step 1 for the first one, resize and grayscale, and same thing, resize and grayscale. And then I'd like to combine them together. So step 2, in step 2, guys, what I'm gonna do, I convert each of these image after resizing and grayscale to NumPy array. Perfect. And I will append it in the list. I call it X. So the list X here, take the first image, then second image, and then the third image, and so on. Each image of this comes 28 times 28. 8 pixel times 28 pixels. Each pixel has a value. So this is 28 times 28. And four images like this. Okay. All right, this X and Y. Anytime I will add an image from the first breed, I will put for Y 0. Anytime I will add any image from breed 2 here, those 2, I will put. So I classify them. So I have X and Y now. Okay. All right. Now, after this, guys, I will convert this to NumPy array. The whole X and Y. Why? Because whole X and Y wasn't a NumPy array, it was list. Okay, so I convert it to NumPy array. And then I will reshape it. How to reshape it? Like this. Say we have 100 image here. More than 100, but 300 because each breed has more than 100. Okay, but each image is 28 times 28. I would like for each image to be one line. Okay, how to do this? 28 times 28, give me 700. You know what? The shape of this X is called shape 0, shape 1, shape 2. So instead of shape 0, shape 1, shape 2, it will be just 2 dimension. Shape 0 and shape 1 times shape 2. So it will be, so this line, it will be the input here. So each image, it will be input one time. Because each image now, it's just flatten as one line will be input on your end. See this in the code, and then we will understand it better, right? Book. Okay, these dogs example, right? So guys, here I make it nice here, and I will share it with you. Okay, okay, guys. This first thing, don't worry about this. Step 1, resize and grayscale. Step 2, convert each image to a NumPy array and add it to XML. Formulate XML. What is step 3? Step 3, convert the XML to a NumPy array and reshape it and normalize it and randomize it. Okay, and then we can apply the dense artificial neural network and can make the test. All right. How can what is here, guys? There's just this for artificial, for this for neural network, sequential, dense for neural network. What's 2 categorical for? Is because this 0 and 1 in Y supposed to be not numbers, supposed to be category. So it will be 0 category and 1 category. So if I have 3 and 4, it will be 2 different categories as well, right? So I will this for the output and this PLT image from public imaging library below can read inside the folder, and this each image will be 5. The size of the image now will be 5 inch times 5 inch, and I ignore anywhere. The first step, guys, is resize. Okay, I have one data set. I call it data one, dogs one. All right, let me show you what's the dogs one. How I did, how does I did it. This one, guys, I need this dogs one. Okay. Dogs one. And here, I come here, in here, Stanford here, and I choose another breed. Okay. What is, I think I took the second one just right after this. This one. Oh, not this one. Toy something, toy. Did you see toy, guys? Did you see toy? Yeah, I took this one and this one. It's called Protein Ridgeback. Download it. Okay, download. Go back. Download it. Still downloading here. Here. Okay. It's right here, and I extract it. Extract it here. And if you want to look at it, guys, look. Right? Is another breed of this. Maybe you are familiar with this type of dogs because I'm not familiar with the names. Because it's called Gene Ridgeback. Oh, I don't know.
It's a Rhodesian Ridgeback.
Rhodesian.
From Rhodesia, former Zimbabwe.
Oh, but I have this. Sorry for that.
Beautiful dog.
I name it dogs too, guys. What it is, I name it dogs too. Okay, let me come here and keep this cut. So I can use it next time. I will come here and I will name this folder and will name it dogs example. Find here the two types. Is that the dogs one and dogs two? This dogs one, which is toy territory, and this Rhodesian something. Right? Oh. Okay, let me. Okay, so I don't need this anymore. All right, so these are two types here. Guys, we need to come here and make like unseen data or unseen dog. So this for test. I will come here and I will take some of them. Any sum of them, like 10, 20. Copy X. I cut it from here and I put it here. And from the other, I should know them. Okay, so I have this just for test. So the dogs one and this dogs two and this for test. Okay, let me now apply data preprocessing for dogs one. So I come here. This is the link for this. Okay, you run this first. To import the TensorFlow and Keras. Mount my drive because I'm put this. All right. Now I will resize and grayscale. So I come here and I make image list. I name it Jack R. I think it has another name. It's called Jack R. All right. Anyway, this image list for the first example, and this is how to resize it. File item in globe.globe for all this folder with dogs1 and with this extension. All right. First thing, what you're gonna do, convert it to grayscale. Perfect. And don't show it to me. It's okay. And now resize it. And now append it to this list. So this list now has the first step, which is resizing and grayscale. If you want to just take a look, if you just want to take a look, that's how to take a look. Right? How to take a look. So for these images, show me the first three. Right? This is the first three, guys. Run it right here. First one, second one. Oh, I have this problem here. The third one. Such file with very called image 0. Oh, you know why, guys? No image 0? Because I took it, huh? Okay. But no, here I did. No. I'd like to save it in somewhere. Let me save it here. So if I run this code again, he will convert it to this list and he will save this list in this folder with this name. Okay, guys, this one. So we name it here process dogs one image live. Okay. Let's do the same step with the second one. I name it image list range empty and look for this dogs2 for any image with this extension, with this format, convert it to grayscale, and then resize it and append it to this list. Our job is done, guys. But just for the sake to see what happened, all right, please just show me the first three. Okay, and after you show me the first three in grayscale, put it in this. Okay, I will create a folder here. Run this code. So everything here and the image for dogs1 and for images for dogs2. Want to look for anyone? It's right here. After grayscale and resizing. Right? So the first step is done. What's the first step again? First step is to go to the first breed, first dogs1, and resize it in grayscale. And then the second one, resize it in grayscale. Second step now, I will convert each of these in the first list to numpy array and add it to X. And for the second list, a numpy array and add it to X. When I add the first list, I add to Y0. When I add the second list, I add to Y1. Okay, so that's what will can happen. Right? List here. Guys, don't look about this now. I will come to this later. I make so two lists, guys, X and Y. Right? For two territories, all right? Go for process dog image live, which is this one. Okay, now we can find it, all right? And open the file and convert it to numpy array and append it. And when I name it array, append it to X. At the same time, append it to Y0. Perfect. That's exactly what we need. Go to now to the second one, which is Ridgeback, all right? Which is here is named process dogs2 image live. Go here, let's navigate here and open the file in anyone and put it in IM and convert it to numpy array and append it to the same X and append it to Y1. You understand, guys? That's exactly what happened here. Convert to H1 to a number and append it to the X and append it to Y0. Convert it to number array and append it to the X and append it to Y1. Right. So if I run this now this image, I have now X and Y full. I have X and Y, all my data now in X and Y. Perfect. What should I do? Right, let me go back to my schema. After this, I convert X and Y to NumPy array and reshape them and normalize them and randomize them. Okay. Let's see. All right, I come here. This step 3, convert XY to NumPy array, reshape, normalize, and randomize. Okay, so here this was list. Now I convert the X to NumPy array. Okay, now look here, guys. Number of pixels, it is X shape 1 times X shape 2. That means 28 times 28, which will be 784. Okay, now the X reshape. What's the shape? X, if you ask me about this before this, what is the shape of X? Can I see? Can I come here? Right, guys, I will come here, show here, and say X. Okay, run it. What I forgot. Oh, this is the list. This is the list. Okay, so I should convert it first to NumPy array, and then I ask it this question. So I can come here. Should I do it? Delete this, delete this. Right? I will come here, guys. I will stop all this code. Here, and I will ask about it. Okay. Not like this. But X. Fine. Okay, guys, the shape is the number of images. Just come from 2 folders and 28 times 28. All right. So here I'm trying to convert it now. Look here, I will do this. The shape 1 and times shape 2, which will give me this number. Okay, and then I will apply the reshape. That's called flatten, but make it one flat. Right? It will be reshaped. The number of images as it is, but these two, it will be okay. Can you this X now? Can you apply this and find the X shape again? Copy. Is when I plug this and apply is the number of images times this. Okay. I hope you understand this part. After this, I will normalize it in easy way. Divide it to 155. Okay, and then I will convert. Oh, I forgot to convert Y to I convert here X only. Okay, and here, guys, Y should be converted to categorical data. But 1 second now. After I did this, here I will randomize it. Okay, how to randomize it? Okay, so I create this NumPy array number from 0 to the length, which 340, and I shuffle it by random, shuffle this, and then for each X it will be X randomized. So that means X will be shuffled and Y will be shuffled as well. Okay, don't forget to convert Y to categorical data. Okay. What's error here? Because I run this twice. So I should come back here to fill X and Y again and run this one time. Guys, if I run it twice, I try to reshape it twice, you cannot find. he didn't find 1 and 2 again, because we have here x changing to this shape 0 and shape 1. Okay, so I will start from x and y again, and then I will run this code again. Guys, I did this. Can you tell me the number of class? I'm sure the number of classes 2, but just to be generic code, and you can use it for your model. Again, please run this code. Run this code. If I ask you for number of class, let me do it in level code. It will be 2, just 2 classes. Okay, 0 and 1. Okay, now we're done with the data pre-processing for this. Now we are ready to apply the neural network. What exactly we have done, right? After we convert it to x and y, we convert x and y to NumPy array, reshape, normalize, and randomize. For y in particular, we convert it to categorical data. The classification problem. Do you have a question, guys? Hello? You okay? You still with me?
Yeah.
Just
Yeah.
about.
I thought I lost you. Okay. All right. Let's apply dense neural network, artificial neural network, like the one we applied before in exactly. Okay. So look here, guys. Don't forget, guys, what is the dimension of the input? Dimension of the input, it will be 784. This means the input layer, it will be 784 nodes. Okay, but also I use this big model. Okay, if you need to read this one, okay. Not correct. Okay, just the input dimension will be with the first layer. Okay, so you guys, the first layer only need to mention. If you ask me what is the order of this times see 784 times 128 times 60 times 64 times 2. So that's a neural network we use now. This is the input layer, and this is the first hidden layer, and the second hidden layer, and the third hidden layer. This is the first hidden layer, second hidden layer, third hidden layer. This is the output layer. The output layer, number of classes. So the output layer, it's 0. It is two neurons, not 1. You got it? You got it, guys? Let me show you here something. No, artificial neural network. Oh, just neural network. Okay, if you look at here, how can we name this? 1, 2, 3, 4, 5. 5 times 5 times 5 times 5 times 3. This input layer and this output layer, and these 3 hidden layers. How can we name this? 2 times 4 times 1. How can you name this? 4 times 5 times 5 times 4. Okay. How you name this? 4 times 6 times 6 times 2. Okay. What about this? This will be this input layer, 84 times 784 times 128 times 46 times 2. Okay. All right. I will talk today about how to choose the activation function. But for now, let's let this go like this. This is the model right here. After I created the model, just like the last time, I compile the model. When I compile the model, what is the loss function? Since it is binary classification, I will call it categorical entropy. Okay, and I use Adam and accuracy. I use this all the time for classification problem. Now I will make fit. What the fit means, train your model, and I take 33% of the data. It will be on the side as a test set. Okay. We talked already about batch size. I remember we talked about 3 types of batches. Important, guys. Important to understand what the 3 types of batches. The whole data set will be one batch, or just each element will be one batch, or we can find many batches like this with a specific number, right? What the verbs means one? Verbs means one means show me the progress for each iteration. And here I'm trying to plot the accuracy and validation accuracy and for training and testing. Okay, so if I run this code, okay, guys, this is our output. This is our output. It's not the best thing, but it's okay. It's okay, right? So the last model will give me a good training set and good test set, right? Is a training with a is a test. Okay. So how many iteration I done? This 20. Okay, right? Of course, guys, you need to change the hyperparameter. What does change the hyperparameter? Change the hyperparameter, change the batch size, change the optimizer. You have many optimizers. Okay, that's all for now. Okay, and this we done this. How to test your model? Okay, I will go here to bring one of the data of the unseen data, with the unseen data. This one. Let's name this Oscar. Okay, and I take this Oscar. I'm supposed to know what the Oscar from, and I'll come here and sorry, here the Oscar right here. I drop it here. Okay, right. Let me see what is Oscar. Okay, Oscar GPG, this one. So to do this example, to find out what the type of this dog, because you already train your model, right? You test your model now to see if your model is correct or not, right? So I show you here the Oscar again. Show the Oscar. Oh, there's Oscar. Oh, this Oscar. I don't think so. Yeah, it's the Oscar right here. Okay. This Oscar. So show me the Oscar here. Okay. Data pre-processing for Oscar. Name it Oscar here. Copy. My Oscar. Oscar. Okay. And processing for Oscar. How to make data pre-processing? The same thing. I start with resizing, and what I name it, Oscar copy. Okay, and I resize it, and I will show it you after resizing. This is data. This after resizing. This before resizing, because I showed you twice. This after resizing. 28 times 28, and then I will convert it to grayscale, and I will show it to you. Okay, my Oscar again. The grayscale. And can you show me print the Oscar if you wanna show to see the data of the Oscar? With grayscale Oscar, right? So it is this the size and this the amount. Okay. So what happened here, guys? I've done the first step. What's the first step? Resize and convert to L mode or grayscale. Now I can X and Y. Remember, guys? Here, that's first step. Now X and Y. X and Y. So I see XT, like X total or X test, okay? And append X Oscar to it. Right? After I convert Oscar to NumPy array. Okay, where here? Yeah, I converted to NumPy array and put X. Right? Do we have to do Y? No, I'm trying to predict Y. Right? Now I convert now the third step. This is the third step now. I convert the whole X to NumPy array, and I'm trying to find the pixel to reshape it here and normalize it. Do we need to shuffle it? No, I have one. No shuffling here. Now I will use my model to predict what's inside X. And I will print the result. Okay, what is the result? Let me show you. This is the result here. So I will look here. This for the type 1, you say is 69%. It will fit from the first type, and 30% from the second type. So I would say here, okay, guys, the result 0, 0, this one, greater than 50%, this from the first type, else it is from the second type. So the same thing here we done with this example, and this example. All these examples similar. Copy and paste. I just changed the engine. That's it. Do you have any question, guys? So since you don't have any question, now guys, I will give you a 15-minute rest. Ready? Happy?
Sounds good.
Okay. So it is 8:11 now on my side. So it will be 26, okay? 8:26 will be back, right? See you after 15 minutes.
Thanks, Ida.
Thank you.